In this last section of Unit 2, we're going to take a look at inequalities. And before we start this, there is a little bit of information that you need regarding inequality signs. The less than sign is always going to be pointing to the left, and one of the words that you're going to see associated with it is smaller. The greater than sign points to the right, and a couple of phrases that you'll see associated with that include more than and bigger. Again, pointing to the left, but this time with a bar underneath it, is the less than or equal to sign. And a lot of times you'll see the phrase at most associated with this sign. Then pointing to the right with a bar underneath it is the greater than or equal to sign, and a lot of times you'll see the phrase at least. In problem number 1A, we're going to look at writing an inequality. So it asks, what inequality represents the verbal expression? All real numbers x less than or equal to -7. So what we want to do is, again, translate this from English to math. When we take a look at the original problem, and it's all real numbers x less than or equal to -7. We're going to take the phrase all real numbers x and just condense it down into the variable x. Then we're going to take less than or equal to, and we're going to change it to that sign. So we have the less than or equal to sign. Then we have -7. So our solution is x is less than or equal to -7. In problem number 1b, we're going to write the inequality that represents the verbal expression 6 less than the number k is greater than 13. So again, start off with the phrase that they gave you. 6 less than the number k is greater than 13. Now remember that less than a number means minus. So we're going to do a -6, and a number k is going to be the variable k, is greater than, so we use our greater than sign, and then 13, we just pull down our 13. So -6 plus k is greater than 13. The way that we would normally write this, we tend to put our variable first. So we're going to write it as k minus 6 is greater than 13. For problem number 2, we're going to determine if a given solution is actually a solution to the inequality. So the question is the number a solution of 2x plus 1 is greater than -3? This is when x is equal to -3. So we write our original inequality, which is 2x plus 1 is greater than -3. We're then going to substitute the -3 in for the x. So 2 times -3 plus 1 is greater than -3. 2 times -3 is -6, plus 1 is greater than -3. -6 plus 1 is -5, and what we know is that -5 is not greater than -3, which means that -3 is not a solution for this inequality. For problem 2b, we're going to do the same thing. The question this time is the number a solution of 2x plus 1 is greater than -3, or we're going to try x equal to -1. So again, we write out our original inequality, substitute -1 in for x, and then simplify. So 2 times -1 is -2. We bring down our plus 1 is greater than -3. -2 plus 1 is -1 is greater than -3. And that is a true statement. So that means that -1 is a solution to this inequality. The next piece of information that you need before we move on is graphing inequalities on a number line. So when graphing the solution to inequalities, you follow these directions. If we have x is greater than 3, you're going to plot 3 on the number line using an open circle at x equals 3. The reason why we use an open circle is because this is a less than or greater than sign. If we have a less than or equal to or greater than and equal to sign, then we'll use a closed circle. What the closed circle is going to indicate is that 3 would be an answer. The open circle indicates that 3 is not part of the solution set. The last thing we'll do is determine whether the variable is smaller or larger than the plotted number and draw an arrow in that direction. So what you can do with this is you want to make sure that you have your variable on the left side. Because if you have your variable on the left side, then that means whichever way your greater than or less than sign is pointing, that's the side that you draw the arrow to. So if you have a greater than sign which points to the right, that means that your arrow is going to be drawn to the right as well. So you can see on our number line that we have an open circle at 3 with the arrow moving to the right. This indicates that every number greater than 3 is a solution to the problem. So 4 is greater than 3. So if we put 4 in for x, we see 4 is greater than 3. That's a true statement. If we said 3.01 is a solution, then we would plug in 3.01, and 3.01 is greater than 3, so yes, that would be true. We could do the same thing with pi. Pi is 3.1415, da 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 da. So you could put pi is greater than 3, and that would be a true statement as well. So that's how you graph the inequalities. Now, what we're going to do is we're going to use this in problem number 3. What is the graph of 2 is greater than or equal to a? So we have our original inequality. What I would recommend, again, is to move the a to the left side. Because if we move the a to the left side, then whichever our arrow is, or whichever our greater than, less than sign is pointing, that's the direction that our arrow on our number line is going to go in. The one thing you've got to be careful of is if you move the variable to the other side, if you switch the sides, then you also have to make sure that you switch your sign as well. So we go from 2 is greater than or equal to a is less than or equal to 2. So once we've done that, we plot a equals 2. Since this is a greater or less than or equal to, we have that equal to component, we're going to make the circle a closed circle. Then, since our less than or equal to sign is pointing to the left, that's the direction we want our arrow to point in as well. And you can see on our graph, we have a closed circle at 2 with our arrow running to the left. In problem number 4a, we're going to write an inequality from a graph. So in this case, when we look at our number line, we have a closed circle on -1, and the arrow is running to the right. So what we'll say is that x is all of those values that are along that arrow. And since the arrow is pointing to the right and it's a closed dot, we know that it's a greater than or equal to sign. So we have x is greater than or equal to. Where is the closed dot at? It's located on -1. So we're going to write x is greater than or equal to -1. The next problem shows us an open circle at 4 with the arrow running to the left. So what we want to do with this one is take a look at which way is the arrow running. And again, that's going to be all of the x values that are solutions. And since it's running to the left, that means that we've got a less than sign because we also have an open circle. So x is less than is what we're going to start off with. Well, where is the circle located? The circle is located at 4, so that means x is less than 4. In our next problem, we're going to look at finding the solution set to an inequality. Now, when we do this, we treat these inequalities in much the same way that we treat equations. So we're going to follow the same set of rules. There's only 1 or 2 major differences, and we'll go over those when we get to them. So we're starting off with what are the solutions of x minus 15 is greater than -12, and we want to graph the solutions as well once we're done. So as always, let's start off with the original inequality. X minus 15 is greater than -12. Well, the entire point of this, again, just like with equations, is to isolate the variable. So since we have 15 being subtracted from x, we want to add 15 to both sides. When we add 15 to both sides, we end up with x is greater than 3. Now, before we move on and graph and finish off this problem, we want to make sure that this is an actual solution to the problem. So what is a number that's greater than 3? Well, 4. So let's plug in 4. So 4 minus 15 is greater than negative 12. What's 4 minus 15? It's negative 11. Is negative 11 greater than negative 12? Yes, it is. So now that we've confirmed that our solution is correct, we can go ahead and we can graph this. So we're going to plot x equals 3 using an open circle. Remember, we're using the open circle again because we have a greater than sign with no equal to on it. The greater than sign points to the right, so that's the way we want to go with the direction of our arrow, and there you have it. The solution is x is greater than 3, and there is your graph. Up next, we're going to write and solve an inequality. So the problem is the hard drive on your computer has a capacity of 120 gigabytes. You've used 85. You want to save some home videos to your hard drive. What are the possible sizes of the home video collection you can save? So at most, what is the capacity of the hard drive? The hard drive can be no greater than 120 gigabytes. So we have less than or equal to 120. How much capacity is left? We have x. Which operation should be used between the remaining capacity and the capacity used to reach the maximum capacity of the hard drive? So, in other words, how much has been used plus how much is unused. So, since we said how much is used plus how much is unused, we're using addition. So, how much has been used at this point? 85. What has been unused? X. So, x plus 85 is less than or equal to 120. At this point, isolate your variable, subtract 85 from both sides, and you're left with x is less than or equal to 35. This next problem relates to compound inequalities. So what compound inequality represents the phrase all real numbers that are greater than negative 2 and less than 6? Graph the solutions. So notice on this one, we've got two numbers that we're dealing with here. We've got negative 2 and 6. So we want to find out what are all the real numbers that are greater than negative 2, but are also less than the number 6. So let's take the phrase all real numbers greater than negative 2 and less than 6, and let's break it down. All real numbers, we're going to say, is x. Greater than negative 2, so we're going to use greater than and just substitute the sign in for it and then bring down our negative 2. And less than, so the less than sign, 6, and pull down our 6. So what we end up with is two separate inequalities. X is greater than negative 2 and x is less than 6. Now we can actually write this as a single inequality. So what you notice is that in one of your inequalities, x is greater than negative 2, you've got a greater than sign. In the other inequality, you've got a less than sign with x is less than 6. What we can do is we can flip the x and the negative 2 to get negative 2 is less than x is less than 6. And then now you've got just one inequality that covers both of them. So once we've arranged the numbers, we're going to place the variable between the numbers. Since x and negative 2 are swapped, the inequality sign we also flipped, and now we have the ability to go and graph it. So x is greater than negative 2. If we have x is greater than negative 2, open circle at negative 2. X is less than 6, open circle at 6. Which direction is the arrow for the x is greater than negative 2 going? It's going to the right. Which direction is the arrow for x is less than 6? It's going to the left. And so what you're going to see is they're going to overlap. Those two arrows are going to overlap between negative 2 and 6. Any value between negative 2 and 6 is going to be a solution of the inequality, except negative 2 and 6 themselves. So let's just pick a number from in between them, 0. If we plug 0 in, then is 0 greater than negative 2? Yes, it is. Is 0 less than 6? Yes, it is, so we know that our solutions are in the right place. So in the last problem we had writing inequalities with and statements. And what happened is our solution sets overlapped in between the 2 points on the number line. And all of our solutions were in between those 2 points. Now we have an or statement. We're going to check out and see how that works. So what compound inequality represents the phrase all real numbers that are less than 0 and greater than or equal to 5? And again, graph the solutions. So take your original problem, numbers less than 0 and greater than or equal to 5, and break it down. So numbers is going to be represented by x, less than, so a less than sign, pull down the 0, and greater than or equal to 5. So with this, we're going to pull the greater than or equal down and make that sign, and then also pull down the 5. So now we have x is less than 0, or x is greater than or equal to 5, written as two inequalities. Now we can write this as a single inequality. 0 is greater than x is greater than or equal to 6. So we've arranged the numbers again, and now we can go ahead and see where are our solutions on the number line. So we've got x is less than 0. We've got a less than, so we're going to put an open circle at 0, and the less than sign is pointing to the left, so we're going to make our arrow go to the left. On the other one, we have x is greater than or equal to 5, so greater than or equal tells us a closed circle. Closed circle at 5, greater than tells us to go to the right, so our arrow is going to go off to the right. So you can see that in this type of question, they're going off in opposite directions. Let's go ahead and check and make sure that this works. And for an or, it only has to work for one of them to make it a true statement. So if we plug in negative 5, is negative 5 less than 0? Yes. Is negative 5 greater than or equal to 5? No. Since the first answer was yes, though, negative 5 is a solution. It's good enough for us. If we were to go over to, say, 10, 10 is less than 0. No, doesn't fit that one. But 10 is greater than 5, greater than or equal to 5, so it fits that inequality, so it would be a solution to it. What about the ones in between? Let's try 2. 2 is less than 0. No. 2 is greater than or equal to 5? No. So we know that anything in between those does not work. In this problem, we're going to go ahead and solve a compound inequality involving and. So what are the solutions of negative 3 is less than or equal to m minus 4 is less than negative 1? Again, graph the solutions. So write out the original inequality. Negative 3 is less than or equal to m minus 4 is less than negative 1. And as always, no difference here, we're going to isolate the variable. Now the variable happens to be in the center of this problem. So 4 is being subtracted from m, so we want to add 4 to every section of this inequality. So we're going to add 4 to negative 3, we're going to add 4 to negative 4, and we're going to add 4 to negative 1. When we do that, we end up with 1 is less than or equal to m is less than 3. This is a solution. So we want to go ahead and graph this and check and see if this works. So we have 1 is less than or equal to m, or m is greater than or equal to 1. So we're going to put a closed circle at 1. And since it's m is greater than or equal to 1, we want the arrow to go to the right. With m is less than 3, we're going to put an open circle at 3, and the arrow is going to go to the left. You can see that the area of overlap is between 1 and 3, 3 not included. So we can check our solution here by using 2. So we're going to plug in 2 in the original inequality for m. So negative 3 is less than or equal to 2 minus 4 is less than negative 1. Negative 3 is less than or equal to negative 2 is less than negative 1. Is negative 2 greater than or equal to negative 3? Yes. Is negative 2 less than negative 1? That is also a yes, so that means that this solution is correct. This next problem is one that you can use for the classroom. We're going to write and solve an inequality, and the question is, to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. You scored 86, 85, and 80 on the first 3 tests. What possible scores can you earn on the last test? So where must your scores fall in between? They have to be greater than 84 and less than 86. What were the first 3 test scores? Your first 3 test scores were 86, 85, and 80. And what are we going to call the last test? Or just call it X. Any variable will work. How are averages calculated? Remember that to calculate an average, or the mean, we add all terms and then divide by the number of terms. So how many terms are you going to have here? 86, 85, 80, and X is going to be 4 terms. So we need to add those 4 terms and then divide by 4. So what inequality represents this situation? Since you had to have greater than or equal to 84 or less than or equal to 86, we're going to go 84 is less than or equal to the fraction 86 plus 85 plus 80 plus X over 4 is less than or equal to 86. Now, where is your variable at? Your variable is in the center section. It's in the numerator, and the entire numerator is being divided by a 4. Before we can do anything else, we have to get rid of that 4. So since the 4 is dividing into the numerator, we're going to multiply everything in this inequality by 4. So 4 times 84, 4 times the whole average in the center, and then 4 times 86. So when we do that, we end up with 336 is less than or equal to 86 plus 85 plus 80 plus X is less than or equal to 344. Combine the like terms in the center section. So 336 is less than or equal to X plus 251 is less than or equal to 344. Again, isolate your X by subtracting 251 from all sections. That's going to leave you with 85 is less than or equal to X is less than or equal to 93. So in order to get a B in your algebra course, you're going to have to get somewhere between an 85 and a 93 on that final test. Up next, we're going to solve a compound inequality involving OR. So what are the solutions of 3t plus 2 is less than negative 7, or negative 4t plus 5 is less than 1? And again, as always, graph the solution. So we already have 2 inequalities broken apart, so we'll just go ahead and rewrite those as 3t plus 2 is less than negative 7, and negative 4t plus 5 is less than 1. On both inequalities, we need to isolate the variable t. So in the first inequality, we're going to subtract 2, and in the second inequality, we're going to subtract 5. That's going to leave us with 3t is less than negative 9, and negative 4t is less than negative 4. Now, since both t's are being multiplied against another number, we're going to divide out those numbers. So in the first inequality, divide out by 3. In the second inequality, divide out by negative 4. By doing that, we are left with t is less than negative 3 and t is greater than 1. So we believe that these are our solutions. So what we want to do is go ahead and graph these. You have a less than sign and a greater than sign, so both circles are going to be open circles. One is going to be placed at -3, and the other is going to be placed at 1. In the first inequality, the inequality sign is pointing to the left, so that's where we want the arrow to go. In the second inequality, the arrow is pointing to the right, so that's the direction we want that arrow to go. So you can see in our graph that they head off in opposite directions. So anything from either of those areas, but not in between the dots, is going to be a solution to this inequality. Now that you've learned how to use the dots, we're going to throw a new wrinkle at you, which is interval notation. And interval notation is going to be something that may be completely new to you that you've never seen before. So the way that this is going to work is we're going to look at our sign, how we traditionally graph it with the circles, and then how are we going to graph it using interval notation, or how are we going to note it using interval notation as well. So our first sign is the less than sign. And traditionally, with a less than, we would have an open circle with the arrow pointing left. Now, what we're going to replace the open circle with is a parenthesis. So in this case, if you had, say, x is less than 3, you would have your open circle at 3, and it would be going to the left. That arrow pointing to the left is representative of negative infinity. So whenever we do interval notation with a less than sign, we're going to have an open parenthesis followed by negative infinity, comma, and then whatever that number is where the circle is, or where the circle would have been. And then because you had an open circle, we're going to use a closed parenthesis to finish off the interval notation. So if it was x is less than negative, or x is less than 3, you would have had open parenthesis, negative infinity, comma, 3, closed parenthesis. For greater than, what we're going to do with this is we're thinking of, okay, where on the number line would our circle be in relation to the arrow? So in this case, the circle would come before the arrow, and that's the way that we're going to do the interval notation as well. So if we had x is greater than 3, what we would do is we would use the open parenthesis, and again, remember the open parenthesis is representative of the same thing that the open circle is representative of, which is to say that that particular point on the number line is not a solution to this inequality. So if we were to use x is greater than 3, we would have open parenthesis 3, comma, and then where is that arrow pointing to? It's pointing to infinity. So infinity, close parenthesis, and that would be our interval notation for that. Now less than or equal to. With less than or equal to, again, thinking on the number line, what comes first? In this case, it's the arrow. Then it's the closed circle. So what we're going to do is we're going to, since the arrow comes first and it's pointing to negative infinity, we're going to use open parenthesis, negative infinity, comma, our point where the closed dot would have been, which we're just going to call x, and because it's a closed circle, we're going to use a bracket. We're going to close it off with a bracket this time. That bracket indicates to us that that number that is in the place of the x is in fact part of the solution. Moving on to greater than or equal to, same thing. Where is the dot in relation to the arrow? In this case, the dot comes first, so we're going to use an open bracket followed by x, or whatever number that point represents, and then comma, infinity, and the arrow indicates to us that it's going off to infinity, so then we're going to use a closed parenthesis. All right, now we're going to see if you've got all that down. So this question is, what is the graph of open bracket -4, comma 6, close parenthesis? How do you write that as an inequality? So the first thing I want to do is I want to look at what is my interval notation. Then once I've got that interval notation set, I'm going to isolate that first value, which is the open bracket with the -4. And what that tells me is that if I were graphing on a traditional number line, I would have my closed circle at -4 with the arrow opening to the right. Then I'm going to look at the second value in that interval notation, which is the 6 with the closed parenthesis. So that tells me that on a traditional number line, I would put an open circle at 6 with the arrow pointing to the left. Now, because I've got two values in my interval notation, the -4 and the 6, this is telling me that on the graph, the arrows are going to overlap. If I had an infinity and a negative infinity, that would tell me that the arrows are going in opposite directions. So with this is going to be an and statement. So imagine the variable between the numbers and the solutions are all between those two endpoints. Now, if I want to put this into an inequality, what I'm going to do is I'm going to keep the order that is shown in the interval notation. So -4 is going to be my first thing. And since that bracket is there, that tells me less than or equal to. Then I'm going to put in my variable, which is x, and then the closed parenthesis tells me that it's going to be less than, and the number tells me 6. So now we go to the graph, and you can see that the closed circle is at -4, and the arrow is pointing to the right. The open circle is at 6, and the arrow is pointing to the left, which is giving us the overlap in between those 2 points, which is where all of our solutions are. Now, to graph this on a number line with brackets and parentheses, all we're going to do is replace the open circle with a parenthesis and replace the closed circle with a bracket. And you can see that in the sample that we've got at the bottom of this slide. We're going to try this with an or statement now. So what is the graph of x is less than or equal to -1 or x is greater than 2? How do you write it in interval notation? So this time we're given the inequalities and we're going to write it in interval notation, and then we're also going to graph. So x is less than or equal to -1 or x is greater than 2. So what this tells me is that if x is less than or equal to -1, that arrow is going off to the left, so I've got a negative infinity. So anytime that I have a negative infinity, that's going to tell me open parenthesis. So open parenthesis, negative infinity, comma, what's the value that x is being compared to? -1. And since this is a less than or equal to, then we're going to use that closed bracket. Then we write or, and then we look at our second inequality, x is greater than 2. So in this case, the arrow is going off to the right, so that means that our 2 falls first on the number line. So we go open parenthesis, because it's a greater than sign, we put in our 2, comma, because the arrow is going off to infinity, we then write infinity and close it off with a closed parenthesis. When we put this on the number line, we're going to use the same bracket and the same parenthesis that we used in writing the interval notation. So you can see that in this case, the bracket opens to the left. So we want to put a left-facing bracket at -1 and then run our arrow to the left. In the second set for interval notation, we have an open parenthesis going to the right. So we want to open that parenthesis to the right and then have an arrow also running off to the right towards infinity, and that's going to be the graph for this problem. The last thing we're going to look at with inequalities involves answering the inequality in set builder notation. So in set builder notation, how do you write the solutions of -5x plus 7 is less than or equal to 17. So we're going to write out our original inequality one more time. Negative 5x plus 7 is less than or equal to 17. And we're going to start isolating the variable. So subtract 7 from both sides, which is going to leave us negative 5x is less than or equal to 10. Divide out the negative 5. That leaves x is greater than or equal to negative 2. So that is our solution as an inequality. Now in set builder notation, it's actually not too terribly difficult, because the way that we've got the solution written in as an inequality, we can actually use that in set builder notation. We don't have to change it to words. We can use what we have there. So remember that with set builder notation, you're going to have an open brace followed by x, which is our variable, a vertical line, then x is greater than or equal to negative 2, and close that off with a brace, and there's your solution in set builder notation.